Now, before we've been handling trigonometrical ratios of angles that are less than 90, that are lying between 0 and 90. And today we are going to look at trigonometrical ratios of angles that are greater than 90. This is Kisembo Academy, and thanks for tuning in. Now, just like before, you've realized that we've been dealing with acute angles. And all trigonometrical ratios of angles that are lying between 0 and 90 degrees are positive. However, trigonometrical ratios of angles that are greater than 90 degrees may be positive or negative depending on the size of the angle and the quadrant in which they are in. Now, by quadrant, this is what I mean. We draw what we call a unit circle. Now, the unit circle is just a circle with a radius of 1 unit. The radius of this circle here is 1 unit. So if you divide this circle into 4 equal parts, each of the 4 parts is called a quadrant. So we have this being our first quadrant, second quadrant, third quadrant, and then fourth quadrant. So to begin with, I would like us to explore these quadrants one by one. We have the first quadrant. The first quadrant runs from 0 up to 90 degrees, and all the angles lie between 0 to 90 degrees. This is our first quadrant. The angle value of theta is between 0 to 90. The second quadrant runs from 90 degrees to 180 degrees. All angles lie between 90 and 180 degrees. This is the second quadrant. The third quadrant runs from 180 degrees to 270 degrees. All values of theta lie between these. All angles lie between 180 to 270 degrees. Then the fourth quadrant lies between 270 degrees to back to 360 degrees. This is the fourth quadrant. So now we get to analyze each and every quadrant on how the respective ratios of sine, cos, and tan, how they become positive and how they become negative. We said, first of all, that all the angles in the first quadrant, all the trigonometrical ratios of the angles in the first quadrant are positive. It means sine of any angle between 0 to 90, cos of any angle between 0 to 90, and tan of any angle between 0 and 90 is positive in the first quadrant. But what about in the other quadrants? Like I said, trigonometrical ratios in the angles in the first quadrant are all positive from 0 to 90. This is our unit circle, so it means that the radius is 1, like we said. Now when we draw our right angle triangle right there, and we form an angle with the unknown angle theta, you find that we have the adjacent being A and the opposite line being B. When you find the sine, cos, and tan of this triangle, you find that they are all positive. All the answers we are getting here are positive answers. The sine of theta is going to be opposite, which is B over hypotenuse, which is 1, which is a positive answer. The cosine of theta is going to be opposite, which is B, or adjacent, which is A, over hypotenuse, which is 1. And tan is going to be opposite, which is B, over adjacent, which is A. And they are all positive answers. We get to the next quadrant, the second quadrant. Now looking at the second quadrant, these are angles lying between 90 to 180 degrees. And when we draw our right angle triangle, you realize that now our value of A is in the negative. So we have negative A here, and of course B is in positive B. Because this is more like x-axis, y-axis. This is the positive, negative part, that's the positive part, that is the positive part, this is the negative part. So if we go ahead and consider this angle, alpha, and we find the sine of alpha is going to be opposite, which is B, over hypotenuse, which is 1. So 180 minus theta is the same as is that alpha. That's what we're talking about. 180 minus alpha it's that. Alpha is that. So sine of alpha is B over 1. Then the cosine, we know cosine is going to be equal to adjacent over hypotenuse. Now cosine of alpha is the adjacent. The adjacent one is a negative over hypotenuse, which is 1. So you find that the answer we're getting here is a negative. And also here for tangent, the answer we're getting is a negative. So it means that in the second quadrant, it is only the sine of the angles between 90 and 180. It's only the sine of those angles that are positives. The rest are negatives. Getting to the third quadrant, you realize that angles running between 180 and 270, our value of A is still negative. Now our value of B is also in the negative direction. So we have negative A here, negative B. So our value of alpha, which is the same as alpha is definitely here, is going to be theta minus 180. So if you to consider this right angle triangle only, the sine of that angle alpha, which is the same as theta minus 180, is equal to at the opposite, which is negative B, over hypotenuse, which is 1. The answer you get here is definitely negative, because it's negative over positive, getting a negative. Same with cosine. The cosine of alpha is going to be adjacent, which is negative A, over hypotenuse, which is 1. The answer we get here is a negative, because negative divided by positive, you get negative. Then for tangent, the tangent of alpha is going to be opposite, which is negative B, over adjacent, which is negative A. A negative divided by a negative gives you a positive answer. So you realize here that in the third quadrant, the sine, it's only the tangent of the numbers of the angles that are between 180 and 270, or the tangents of the numbers between this quadrant are the ones that are positive. The rest are negative. In the fourth quadrant, you're having alpha right there. The angles are lying between 270 to 360. So when you draw your right angle triangle and you consider that alpha, the sine of alpha, which is the same as 360 minus theta, is going to be equal to opposite, which is negative B, over hypotenuse, which is 1. So the answer here is a negative. Cosine of alpha is going to be equal to adjacent, which is A, over hypotenuse, which is 1. And then the tangent of that of alpha is going to be opposite, which is negative B over A. So you realize that here the answer we are getting here, it's only the cosine here that is positive. The rest are giving us negative answers in the fourth quadrant. So all that brings us to 1. This is the first quadrant, the first quadrant, the second quadrant, the third quadrant, and then this is the fourth quadrant. Now, we can only just adopt an acronym called ACTS. For those who read the Bible, we know that book called the Acts of the Apostles. So just ACTS, you take that acronym. And that ACTS simply signifies that in the first quadrant, all are positive. Sine, cos, tan, or all angles in the first quadrant are positive. In this fourth quadrant, only the cosine is positive, just like we had said in the first quadrant. Only the cosine is positive. In this third quadrant, only tangent is positive. Like we had seen here, only tangent is positive. And then in the second quadrant, only sine is positive. Only sine is positive in the second quadrant, like we had seen. So just have to memorize this acronym, ACTS. And so when you're calculating numbers, you just remember that ACTS, all in the first quadrant are positive, only cos is positive and the rest are negative. Here only tan is positive and the rest are negative. Only here sine is positive and the rest are negative. Let's do some numbers. Without using tables or calculator, find the values of sine of 150. So now looking at the sine of 150 here, let's draw this. Sine of 150 lies, we start from here 0 degrees, this is 90, so 150 lies around here. So 150 degrees. So if you look at sine of 150, it's lying in the second quadrant. This is the first, so the second quadrant. So since it lies in the second quadrant, from here to there, that is theta is going to give us 150 degrees. Now what's the value of this remaining angle? The value of that remaining angle is 30 degrees. It is 30 degrees. Because 150 plus 30 is 180. This whole thing is 180. So 180 minus 150 get the 30 degrees. So it means that the sine of 150 is the same as the sine of 30. So you look for sine of 30. What is sine of 30 according to our trigonometrical ratios? sine of 30 is, now according to our trigonometrical ratios, we said that the sine of 30 is a half. We did this in our previous videos. So the sine of 30 here is a half. And that's our, now, is it a positive or a negative? According to what we've just explored, we say that only sine in this quadrant are positive, the rest are negative. So it's positive a half. We go to the second, tan 300. So to find the tangent of 300, we need to first find out in which quadrant is tan 300 lying in. So again, we are going to draw our grid, our unit circle. And when we move from here, 300 is, this is 0 degrees, it runs to 90, it runs to 180 degrees, then this is 270 degrees. So it means 300 degrees lies between 270 and 0 degrees. Remember, when we are taking, we say 300 degrees, we start counting that 300 from here, moving that side. 90, 180, 270. So 300 lies somewhere there in the fourth quadrant. So if 300 degrees is lying within the fourth quadrant, what angle is this that has remained? So it is going to be, here it's 360, so it's going to be 360 degrees minus this 300. Here it's 300. And then you remain with 60 degrees. So it means that here you have 60 degrees. So now, you ask yourself, they want the tangent of 300. So the tangent of 300 is the same as the tangent of this 60 degrees. And so what's the tan of 60 degrees? From our ratios earlier, we say tan of the tangent of 60 is, from our ratios we say that tan of 60 is root 3 over 1. So it means tan of 60 is root 3 over 1. Now, is this tangent root 3 over 1, is it positive or negative? Going back to this, we said that in the fourth quadrant, all the values of cos, all the cosines of those angles in the fourth quadrant are positive, and the rest are negative. So it means that this answer is negative. Negative root 3 over 1. That's our answer, or negative root 3. This tangent of 495, still we need to identify in which quadrant does this one lie in. So we begin. So you realize that 495 degrees is even beyond 360. So it means we move one revolution, that is 360. Then plus 360, how much more are we supposed to move so that we reach 495? So 360 plus 90, what do we get? So 360 plus 90 degrees. Plus 90 degrees, we will end up with 450 here. 450 degrees, we've not yet made that thing. So we move again, plus another 90 degrees to reach that. So when we add another 90 degrees, we come here, this is 540. So meaning that this angle, 495 degrees, is going to lie between 450 and 540. So it means that this continues up to there, so it lies in. 495 is somewhere in between here, there. So it's lying in between, it's in the second quadrant, this angle. So now after identifying that it's in the second quadrant, we need to find out this remaining angle. What is that remaining angle? Of course here, this remaining angle is going to be 540 minus 495 to get this remaining angle. And 540 minus 495 gives us 45 degrees. So we have 45 degrees. So it means that the tangent of 495 is going to be the same as the tangent of 45. From the ratios we explored before, our tan of 45 is 1. So if our tan of 45 is 1, we need to find out, is this 1, is it a positive or a negative? Now this is lying in the second quadrant. And in the second quadrant, only values of sine are positive, so the rest are negative. So it means that our 1 here is negative. Please remember to share this video on other video sharing platforms and also subscribe and hit that like button. Thanks for watching, and this is Arnold Rangakoramia for Kisembo Academy.